Okay, so we're looking, all we really need are three items here to really establish some sort of criteria what's going on. We have an 18, we're turning it into a 6. So we can say we're subtracting 12, but if I try to do that again, I would definitely not have a 2. So the other option then is to take 18 and divide it by something to get to 6. And we divide it by 3, I'm here. You divide that by 3 again, you end up with a 2. So that means we have to divide by 3 as we go. Well, 2 divided by 3 is going to give me a 2/3. And if I keep dividing by 3, I'm multiplying the bottom by 3. And so that would mean this would be a 2/9, and it would be 2/27, and so on beyond. And as if I go back the other way, I'm dividing as I go to the right. So if I multiply by 2, I get a 6. Or, I'm sorry, by 3. If I multiply by 3, I get 6. If I multiply by 3, I get 18. So if I multiply by 3, I'm going to get my initial value, which is the 54. The criteria here is that I'm dividing by 3. And just for fun, if I understand that this is my initial value, the equation in sequence notation is going to be 54 times 1 over 3, which means the same thing as saying divided by 3 to the n power. So the criteria is this. This I threw in just for fun because that sure was fun. Now look at this. I take 18. I got a 6 again. It could be the same thing until you get to here and realize, okay, well, I'm not dividing by 3 this time. I'm subtracting the 12 that I mentioned up here. Subtract by 12 again, you get the -6. Keep subtracting by 12, you get a -18, a -30, and so on, -42. So to go back the other way, if I'm adding 12, I get to a +30. Okay? Interestingly enough, we reach 30 in both cases. That's because there's a difference of 60 and 12 goes into 60, just FYI. So we are, as we said, subtracting 12. And again, just for kicks, I'm going to write the linear equation, or the arithmetic sequence, that has an initial value of 30, but it's decreasing by 12. So I've got a -12n plus 30. Again, that was for free. -4, -8, -16. It's increasing. Well, it's decreasing by 4 and then decreasing by more. Okay, so we can't say that it's arithmetic. We can't say that it's linear. We are multiplying. So this is going to be a -32 and then a -64 and so on. So if I'm multiplying by 2 this way, I'm dividing by 2 going this way. I'm left with a -2. We're multiplying by 2 as we go, but our initial value, again right here, is a -2. So if I start with a negative, it's going to remain negative if I'm multiplying by a positive number each time to the n power. And again, the first two look exactly the same. So you might say, oh, I'm multiplying by 2 again, but I'm not. I'm subtracting 4, subtracting 4, subtracting 4. So I've got a -16, -20. If I add 4 to go the opposite direction, I'm stuck with a 0. So this time I'm subtracting 4, and so therefore I am going to be another arithmetic sequence where the -4 is my multiplier, like -12 was here, times n plus 0 just for kicks to show that that is in fact our initial value.